Good day, learners. Today our topic is about scientific notation or writing a number into standard form. So what is the purpose of the scientific notation? It is a convenient way of writing very large or very small numbers. Because in science, if you have physics, chemistry, or biology, usually we encounter very large numbers or very small numbers in which it's very inconvenient if we are going to write it in that way. So we have the standard form. So if we have a large numbers, the exponent of that number will be positive if we are going to write it in standard form. If we have small numbers which is less than 1, the exponent of that number when we write it in standard form will be negative. Okay, what do we mean by standard form? When we say standard form in our scientific notation, it means that the decimal point must be after the first non-zero digit. Because here and here, we are going to move our decimal point. So the decimal point must be after the first non-zero digit. So let's have the first one. We have a large numbers here. This one is 35 million. This is large. You should know what a large number is or a small number. Usually a small number is, it has a decimal point on the left. While very large numbers or large numbers, they don't have that decimal point. Usually, you don't see any decimal point there. So the decimal point of very large number is on the right side of the digits of the number. So let's have number 1, 35 million. Locate first the decimal point. Where is the decimal point of 35 million? If there is no decimal point, then the decimal point is here on the very right of the number. Okay, where are we going to move our decimal point so it will be after the first non-zero digit? So we will move this decimal point from here to here, in between 3 and 5. 3 is the first non-zero digit after that. So after the 3, we have the decimal point. So in standard form, you have 3.5 and then you write times 10 and then count how many movement of the decimal point from here up to here. So you have 1 here, 2, 3, 4, 5, 6, 7. So our exponent is positive 7 because this one is a very large number. Number 2. Okay, let's have the comma, thousands. So this one is 185 thousands. Now, first locate the decimal point. So the decimal point is here, which is usually hidden or invisible. So 185,000 is a very large number. So it means that our exponent here of 10 is positive. So you don't put any more the cross for positive. Just leave it. Okay. Now we are going to put this one into standard form, meaning we are going to put our decimal point here in between the 1 and 8 after the first non-zero digit 1. So that decimal point must be here. So we write here 1.85. The decimal point is here. Okay. Times 10, then we count from here up to here. So we have 1, 2, 3, 4, and 5. So our exponent is positive 5. Number 3, we have 5,000. So for 5,000, the decimal point is here. Now we count up to here because this is our first non-zero digit after the 5. So we write here 5 times 10 and then we count We have 1 and 2 and 3. So that is 5 times 10 to the third power. So these examples here are for the large numbers. Now let's have the small numbers. So we have here point. You see here the decimal point. You can see the decimal point. While in large number, you don't see. Usually, we don't see the decimal point. It's invisible. Here, it is shown. You have to show that this one is less than 1. So, have the decimal point here. You can see the decimal point here. And for number 3, you can also see the decimal point here. So, where are we going to put again the decimal point? If you are going to write that one in standard form, between the first non-zero digit. And that one is the 7. So we don't write the decimal point before the 7. It's after the 7, the first non-zero digit, which is 7. So here, so we have 7.8 times 10. Because we know this one is a very small number and we can see the decimal point, you write a negative sign there because our exponent will be negative. And then we count from here up to here. So we have 1, 2, 3, 4. So we have negative 4. Number 2. Okay. Where's the decimal point? Here. Where are we going to put the decimal point? Here. The decimal point is not there. The decimal point is here. It's a small number. So this one becomes 5.85 times 10 to, that's negative because this one is decimal. So we have negative, and then we count, we have 1 and 2. So we have negative 2. Okay, number 3. Sometimes we need to round off our numbers. Usually when the number is a result of the computation in our calculator. So the calculator display sometimes will display a very long numbers, maybe 10 or digits or more. So we need to round off. If we are going to round off this one class, so it will become 0.6 because this one is 9. We add 1 to 5. So this one is 66. So if you drop that one, that becomes 0, but that one is useless because we are going to put our decimal point until here only. We're not going to place our decimal point here. So until here, 0.66, we have the decimal point. It means a small number. So this one will become 6.6. And then you may add 0 if you want, but we don't need that one. So we have times 10, and we know it's negative because it's a small number. And then we count from here to here. So we have 1, so we have negative 1. And that is how to write ordinary numbers or regular numbers into not only scientific notation, but in standard form. Now we know how to write regular numbers into scientific notation or standard form. This time, class, we are going to write standard form into regular numbers. We know that if the exponent is positive, then it is a large number. If the exponent is negative, then we have a small number. We have positive exponent here. We have number 1 is 4.25 times 10 to the third power. Now we are going to remove this times 10 to the third or 10 times 10 to a number. For positive exponent, we will move the decimal point to the right. Move DP decimal point to the right. So the 4.25 here, that decimal point, we will move that one to the right by 3 movements. So why not we put here the 4.25 here, and then 3 to the right from here. So 3, so we have 1 and 2 and 3. The decimal point is here. There is a missing number here. What is that number? It's 0. So you place 0 there, but right again. We clean it. So we have 4,250. Decimal point is there after the 0. Number 2, we have 6 times 10 to the 5th. Positive exponent means we are going to move the decimal point of 6 to the right. 5 movement. So where is the decimal point of the 6? We don't see the decimal point. It means it is understood to be here after the 6. Now 5. We count 5 to the right. So here we have 1 and 2 and 3 and 4 and 5. So the decimal point is there. But we don't have anything here. So what do? We place 0 as if there's a basket. 0, 0, 0, 0. So we write again. So you have 6 and 1, 2, 3, 4, 5. So you have 1, 2, 3, 4, 5. So you can put a comma there. Means it is 600,000. We have 2.54 and that is positive 6. So we are going to move our decimal point 6 places to the right. So we write it again. So we can count 2.54 here. Now count 6 from the decimal point. So we have here 1 and 2 and 3 and 4 and 5 and 6. Decimal point there. There is nothing here. So you have to place 0. 0 here. 0, 0, 0. Okay. And then copy again. 254. And how many zeros? 1, 2, 3, 4. So you have 1, 2, 3, and 4. You may put a comma here to separate it by thousands. So you have 2,540,000. So let's have now the negative exponent. Negative means we are going to move our decimal point from the standard form to the left because negative means it's a small number. So 8.65, this one, you see, they are all in standard form. So right here, I'm going to place here the 8.65 far from this one because we are going to move to the left. So I have 8.65 here. I'm going to start from the decimal point here and count 5 to the left. So we have 1 here, 2, 3, 4, and 5 here. And then you put 0 here, 0, 0, 0. And then you may put also a 0 here, but the 0 is not counted. It's like for display only. So write again. You may put the 0 and then count. This one, the 4 zeros are important. 1, 2, 3, 4. So we have 1, 2, 3, 4, and 8, 6, 5. Can you add 0 there? If you like, you can add zeros. 1 0, 2 zeros. But the most important zeros here are the 4 zeros after the decimal point. We have 3. So I'm going to write here because we are going to the left. Where's the decimal point of 3? We don't see anything here. So it's here. We're going to the left by 3 places here. So we have 1 and 2 and 3 decimal point. So put the 0 here and 0 here and the display 0. It is not counted. So we have not counted and 1, 2. Okay, 0, 0, 3. And number 3, so we have 4.78 times 10 to the negative 1. So we have 4.78 here. Negative 1, 1 place to the left. So here is 1. Okay, here. So our answer here is, I'm going to put 0 and then the decimal point is here. And then we have 478. And that is how to write standard form into regular numbers or ordinary numbers.